Welcome everyone to episode number 3 of PyTorch Community Voices, a weekly webinar where members of the PyTorch community showcase how they use PyTorch or what they have built using PyTorch. My name is Suraj Subramanian and I am a developer and developer advocate at Facebook AI. Joining me today as co-host is Jessica Lin.
Hey everyone, like Suraj says, I'm Jessica Lin. I am a developer advocate here at Facebook as well, focused on our AI ML products. So I'm really excited to have you all here.
And today we have Alex and Bing from AutoDesk. Welcome, Alex and Bing, to the show.
Hi, thank you. We're very excited to be here.
Would you like to introduce yourselves to our viewers?
Sure, absolutely. So my name is Alex O'Connor. I'm a senior manager in data science and machine learning at Autodesk. We work on the e-commerce and customer empowerment team, and my background is in natural language processing.
Bing, I think you might be muted. Oh no, you're not muted.
Hi everyone.
Right.
My name is Bing. I'm a senior data scientist on the same team of Alex. My background is also in natural language processing.
Nice.
Great.
Well, thanks for joining all. So thank you both for joining us, and we're really excited to have you here to talk about how you guys use NLP transformers at Autodesk. So the format of the show for those joining us will be our two guests will do a presentation about their project, so about a 15 to 20 minute presentation. And then throughout that time, if you are in the audience, please post your questions. So we will be asking your questions to our guests today. So please feel free to ask away. And yeah, so with that, we'll turn over the time to Bing and Alex. Are you ready?
Yeah, fantastic. Thank you.
All right, sounds good.
All right.
So thank you everyone for joining. This is a great opportunity for us. We've been excited to work with both the Amazon and the PyTorch teams on this project, and it's worth acknowledging that both sets of teams have been a huge help to us in both communicating the value of this work and in doing it. So I wanted to start by talking a little bit about who Autodesk are. So our company is about 40 years old. We started in the early 80s in design and technology, and it's fair to say that basically anytime you see a product that's got a manufacturing or design component to it, whether it's real or virtual, whether it's a large scale like a building or a skyscraper, or a small scale down to some of the smallest 3D printed components that you see, there's very likely that one of our products has been involved in the development of that system. So we have this tremendous range and depth of use of our products, and it's an extraordinarily valuable community and a global community of professionals who use our software every day. So some of the key products that you may have heard of are Fusion 360, our 3D printing tool, AutoCAD and Revit, Inventor, and Maya, and 3D Studio Max. And there are a number of other products out there as well. And one of the great things about that is that means we have these users who have an enormous need for high quality support and who need rapid help with the problems that they need to face, and are managing things on a professional basis. So, have hundreds of users, have themselves got tight timelines and a real dependency on us. So one of the things that we need to do is provide the kind of support we can to our customers that scales to their needs. So that means ranging from relatively simple tasks like finding the correct downloads, finding the correct account settings, all the way up to very complicated technical support questions. And our intent is to be able to serve those things in a way that is fast and customer friendly at all times, and develops a better relationship between our customers and makes them continue to be involved with us. So we have, as part of our work, this chatbot that we use as a core part of our support strategy. So 100,000 customer questions a month come in to what we call the intent model, to the Autodesk Virtual Assistant, or AVA. And you can see a kind of a representation here of some of the typical examples of the sorts of products or questions that we get in from our customers that we can serve. So for example, you can see there are things like just simply finding the correct download can be something that can be greatly assisted for a user in a chat environment, because you can get them to the right product, get them to the right version, and check those sorts of things. Often users need to add and manage seats. So with our software, you can imagine that you have you buy a certain number of licenses, and you need to then be able to manage who is specifically using those licenses at different times, so that if I manage a team of 500 engineers or 20 architects or 3 digital artists, then along the way I need to be able to do things like add a user, move a user, change the allocation of licenses for a user, and all those sorts of things. And finally, we have a significant amount of support which we provide for our student users, who are often in university or in formal and informal education. And what they're often trying to do is be able to learn the software, become design professionals, and be enabled by our software when they do that. And so we provide support to them through our automated channels principally, and that allows them to do things like learn to become 3D animators, architects, designers, 3D printers, all through their professional courses. So that means that we have a huge variety of users that are coming in with all sorts of questions. And our core mission with Ava is to provide this conversational layer around support that allows users to get meaningful answers and task-oriented results, so that we don't want to be in a situation where you're just kind of reproducing the website, but instead what you're being able to do is help users directly support the answer. So from a machine learning perspective, what is the kind of thing that we want to look at here? What is the system design that we're interested in? Well, we want to be able to design something that maximizes flexibility and maximizes efficiency from both sides. How do we there's no need for a customer to spend a long time waiting for a real agent if we can solve their problem virtually and quickly at the scale that they need. So you can see that we want to combine the ability to have both open text and push button input, because a key challenge in conversational design is discovery. Very often you just present people with an open chatbot, they don't know what to do. We would like to be able to use multiple different models so that we can separate concerns. Very often different flows and different types of tasks benefit from different approaches from a machine learning perspective, and over time you get shifts in the way that the users ask queries and what kinds of queries get asked. So being able to coordinate different models, coordinate different approaches inside one orchestration layer is an essential part of the power of a platform-based approach to chat, which is what we've adopted at Autodesk. And so you can see that on the right here, we have a sort of a simple example of the kind of minimal interface, or sorry, minimal conversation that you might have. The bot introduces itself, and then simply someone says download, and we go through the flow there, where they're given a widget that actually gets them all the way to the specific product query that they want. And that's the key point here. People can arrive with the level of specificity that they know, and that they can then get the answer that they need, develop that answer over time. And that's a critical value in a conversational approach, is that I can arrive, a bit like a search, I can arrive with a loose specification and it can guide me towards a fine-grained result. Key to all of this, though, is being able to have fine-grained analytics along the way. We need to watch for shifts in customer queries. We need to be able to watch for what flows are successful and what are unsuccessful, and compare in all the comparative fashion that you imagine what the right response is along the way. So from an inference requirement, this creates quite strict needs. We need to be able to respond quickly, because we can't have long delays, because users get frustrated. They also just think it's not working. It's often in a situation where you only have a batch of one, because customers can jump around. They can type one message, try another one. They may or may not change their minds and go in a different direction. So you don't have this opportunity to be able to batch up large numbers of queries at once and perform inference on them in a piece. It needs to be cost effective. We scale substantially over our user base. We need to be able to make sure that we can maintain the responsive layer quickly, and we need to make sure that we want it to be able to be done in a fashion that allows us to expand the number of tasks that we can provide to users without that being something that becomes prohibitively expensive. Because if we find that users like this, we want to be able to support as many things as possible through them. From an infrastructure perspective, that means that we want to be able to easily package the models, easily get whatever we want out to deployment fast, and iterate quickly, because that also means sometimes we need to withdraw models or change models as different changes become apparent in our analytics. So we want to be able to do something that allows simple deployment and at least equivalent performance or better in terms of the quality. So for us, these are very strict requirements. This was one of the challenges with rolling our own model and with deploying our own infrastructure in terms of chat, is this question of how do you do all of these things in an interactive fashion? So we've turned, like many groups, to the transformer-based model for attacking the natural language processing problem. And transformers now are 3 or 4 years old. They're well established as an approach. Well, really 5 years old. They're a well-established approach to natural language processing. They're state-of-the-art, especially in English, for many of the natural language processing applications that you might want to do, especially text classification and sequence-to-sequence models, as well as language generation. So what intuitively you might think of as being a transformer, what the underlying layer does is that what happens is that you have this multi-headed self-attention, where the transformer learns the meaning of tokens of byte pairs based on the most common words that surround it. So that means that you learn the meaning of words from the others around them. And in simple terms, that means that as you train these larger and larger models, they're able to learn different types of contexts, so that one word, such as bank or set, might have numerous potential meanings, but over time, based on the other words that surround them, you begin to understand what those means. And that's especially important for us because we have a lot of technical language in our work. So things like words like line, segment, staircase, helix, all of these things have different meanings for our people. So we train this large general language model, or someone else does, and then we are able to fine-tune it for our specific task. So in very simple terms, that's how it works. And I'll go through this relatively quickly, but you can refer to the AWS link that we'll show on the next slide as a way to going through in more detail. But basically, you say to yourself, find your data, choose your task. In this case, we're going to try and classify customer queries based on an intent, and then fine-tune this model to allow it to perform the specific task of classification. Train the model, and you get your results fairly quickly. And the nice thing about this is over time, this has gone from being a very laborious process to being one that's very quick. So in SageMaker nowadays, you can see that based on the very recent Hugging Face implementation of the SageMaker interface, that can be as simple as a relatively small number of lines of code, mostly around managing what kind of instance you want and your input and output data. And this here, by the way, is the key base model, as we call it, which is the underlying starting point for your model. And in this case, that model is a DistillBird based on case. So it's a distilled, so it's a short, reduced size model that doesn't concern itself with case. And so you can see that based on all of this, you get a very simple set of data, a very simple set of code that allows you to get to training very quickly, and you can compute your metrics in any way that you like. So you have this very simple and very straightforward approach to training the model, and that allows you to get to pretty high performance pretty quickly. And from there, it's very much about choosing different base models, choosing different hyperparameters, and most of all, choosing better metrics and better data sets. So you have your training model done. You have built your model in relatively few lines of code. And the big challenge that used to arise then was, what do you do next? Because these transformers are huge models. They have between 300 million and, well, billions of parameters. They're large. Baseline models can be 70 or 80 megabytes. How do I load that and infer effectively on it without scaling my costs extraordinarily? Because if it requires GPU or some other custom inference, you won't be able to do CPU inference without substantial change to the code. And I'll let Bing take over, and she will talk a little bit about how, once you've trained it, what do you do next?
Thanks, Alex. Can we go to the next slide, please? So I talk about how we deploy a transformer for Ava. We'll start by training and saving a model offline. And usually we use transformers models for Ava a lot. And then we need to upload the model into S3 buckets. We will prepare a Docker file, the library requirements files, the inference scripts for a Docker inference image, and then we'll create the image, create a model in SageMaker, and finally we will create endpoint configurations, the endpoint itself, and when we do the inference, we just invoke the endpoint. So that's how we deploy a transformer in a traditional way. Next slide, please. And like Alex mentioned, transformer models are usually huge, and when we do inference, it's very costly, and it could take a long time for the inference to get done. And there are some ways to try to save the time and cost. And examples of these approaches are distillation and quantization. And distillation is where we just teach a student model from the original model to mimic the original model's performance. And for quantization, we're doing an approximation for the original model. The issue with both these approaches is that we are compromising the model performance, and it's not guaranteed that we're having the same great transformer model performance when we actually do the inference. So when we see Inferentia, we just can't wait to try it. Inferentia is the first machine learning chip by AWS that enables high performance deep learning inference applications, and it's claimed to have the highest throughput, but only at almost half the cost per inference when we compare it with GPUs. And Neuron is just the SDK for running the machine learning inference using AWS Inferentia chip. And it's very easy to do the compilation of models. It's a minimal change to your original model code. And you can compile the model for Inferentia within a SageMaker notebook. And then just deploy the compiled model to an inf1 instance, which is the instance that's using Inferentia chip. And our team did a benchmarking. And when we do the inference, we just need to create endpoint configurations endpoint, similar to the traditional way of doing it. And then when we do the inference, we invoke the endpoint. So as you can see on this slide, the tracing for Inferentia is very easy. We just need a couple lines of code to get the model loaded using tokenizer and load the model. And then we just need to use neuron trace to compile the model and finally save it as a torch script. Then the torch script file can be used to get deployed on an inf1 instance. Next slide, please. And the benchmarking procedure we used was we trained the model and save model offline, and we actually did the benchmarking proof of concept on top of our intent model for AVA. And we compile the model using Neuron and generate the torch script with just the few lines of code that was shown on the previous slide. And then we create an inf1 instance, upload the model onto the instance, and then SSH into the instance and run some benchmark script. And finally, we were able to save the results. The next slide shows the benchmarking script that we used. We just create a couple lists to save the throughputs, the different quantiles for the latencies. And then as we go through the inferences, we just save the throughputs we see and the latencies. And then we save everything into a table and then into an CSV file. The benchmarking result was really good. We did a comparison between the inference of intent model on an inf1 X large instance and also a G4 X large instance, and we see a 4.9 times higher throughput on the inf1 instance, and the latency was about half. So it's really very good result. And so the summary of the benchmarking result was that we see the Inferentia.
Oh, sorry.
Inferentia really provides us a way to efficiently host transformer models without any compromise on the model performance. And the benchmarking result showed a 4.9 times speed increase and very stable latency. We also observed that the process is very low developer overhead. There's minimal change to our model code. And the compilation process is also very simple. Some next steps that we are considering, One thing is that we will look deeper into the neuron core pipeline, as there are some other approaches that we see might be worth trying out. And examples of those are multiple neuron cores and also caching model parameters. We'll also try some different inf1 instance sizes, as we will only using an inf1x large instance in the benchmarking proof of concept. And we're also looking to check the neuron runtime and profiling, and these seem to be very handy tool to understand the whole inference process. And we're also applying Inferentia to the deployment process of our other NLP models. And for some of our models, batching might make more sense when we're probably having more inferences needed at a time. So yeah, so that's it.
Just add to say that if you want more details on this, we have an article with the PyTorch blog. The link is there, along with a QR code for the page as well. Great.
Nice. Well, yeah, thank you so much for that very thorough walkthrough of how you guys were able to implement like PyTorch and then use Inferentia and really build out this like cost-effective production-size chatbot. So I know we definitely have we have a good question in the chat from our guests, and we also do have some questions as well between myself and Suraj. So we'll jump into that next portion of the show. So do you want to take that part, Suraj?
Yeah. I'd just like to recap for those who may have missed our intro. We are currently talking with Alex and Bing, who just gave us a wonderful presentation on how they productionized an ensemble of transformers to build their own chatbot at Autodesk. So I see Thomas, who was our first guest on the show, has a question about, he asks, how do you keep tabs on how well the chatbot does when deployed? Thomas had presented on Torch Drift, his library that detects model drift. And I am also personally curious to know how, what did you use to detect when your model was straying away from the data that it was trained on?
Alex, do you want to start?
Sure. I think it's a very pertinent question. There's a lot of challenges with a chatbot. One is to understand whether or not you're making the correct prediction at a model level. So is the intent coming in correctly from the user? Are we sending them in the right direction? And then secondly, is the thing that we're sending the user the correct answer? So extrinsic to the model task is that second task, which is, are we serving their solution? So we need to account for both things when we think about that problem. And so when we do analysis, we look at both kinds of challenge. So Bing, you've done quite a lot of work to kind of cluster and analyze inbound customer conversation and look for outliers. And then secondly, we also look at customer feedback in terms of customer satisfaction and where they land in our escalation flow. So there's always this thing with chatbots that you need to be able to provide a way to talk to an agent quickly if it doesn't go right. And we look at the rate for that as a kind of a baseline for how well we're doing. And we've found substantial reductions in those with the improved models that we've been able to deploy.
Yeah. Probably to add on to that, we're also looking at the incoming requests, and we want to see is there any special changes to the request. Probably there are anomalies, and we're trying to actually this is the new thing that we're adding to our monitoring process.
Thanks. I am curious. I just want to bring my question in over here. 5 years back, Microsoft had released a chatbot on Twitter, which learned from interactions on Twitter itself and quickly devolved into a disaster. And cut to the chase today, where chatbots are ubiquitous. We have one in Alexa and Google Homes and everywhere. I'm curious to know if Ava had any memorable moments where the chatbot may have posed some amount of risk or some threats to Autodesk?
Yeah, good question. So I think the Microsoft experience was unique in that they relied on the crowd training to both generate the responses and the recognition. We obviously don't. We pre-write our responses, so we don't have the same kind of concern in that sense. But we did in early versions of the chatbot have a wide variety of intents, so much broader kind of conversational type experiences for the customer. And the risk that did arise there was sometimes legitimate queries would be confused with less serious questions. So that would cause a great deal of frustration because someone was coming with a serious question and the bot would misunderstand them. So we learned relatively early on, to reduce the scope of the model to very much the type of things that you would specifically want to do, and stay at that kind of level. And I think you can see the challenge that I think a kind of a takeaway from that is to very well understand what you're doing with your chatbots. So Alexa has this wide variety of things it wants to do, but people sort of expect it to be kind of chatty and funny and have a personality in that sense. People don't really come to our customer support bot for a personality so much as they do to get an answer. And so we've restricted what we could do to what we can deliver well on, and that's been a real advantage to us. But yeah, I mean, I think a lot of people come in with let's do everything, let's make a general intelligence conversational system kind of attitude, and I think that's often a mistake in that sort of thing.
Yes. And so when I actually started working on the intent model, like Alex said, I started by some work and analysis on limiting the number of intents and really understanding which intents would be helpful for our customers, and also from the self-serviceable kind of perspective. But right now, I'm also seeing there's a trend to going beyond intents in the NLP world. So I'm very excited about that. But I think the basic idea behind is to keep learning and understanding which intents are really useful, and from the data perspective. So yeah.
This obviously seems like a lot of work, and one of our viewers on YouTube, Fräulein Campos, has a very relevant question. He wonders, how long does a project like this take before rolling it out to the public?
Oh, quite a while. I think so there's kind of two answers to this question. One is we had to develop a lot of background of kind of data of customer queries which we could build our chatbot from. So one of the biggest challenges if you're a new company or if you're a new project is, what do you use as your baseline for your data set for customer queries? Because the way people talk to chatbots is slightly different to the way they might send an email or those sorts of things. So there was a long time in collecting that sort of data. And then I think it took quite a bit of analysis from this is Ava now in its third or fourth iteration, and the project has been running for a number of years, but because of this need to get the intents right, to understand which ones are prioritized and which ones we can effectively serve. If you wanted to do it really quickly, I think you could probably we've been able to turn new models around in less than 6 months, but that's to kind of production size.
So I actually have a question, kind of going back to Bing's discussion about using intent models. Are there interests? Do you guys have plans for implementing other types of models beyond this,
Yes.
what you currently have in the ensemble?
Absolutely. So we have a couple NLP transformer models working behind Ava together. So there's definitely a chance for us, or we're actually trying to use Inferentia as a regular practice for deploying our transformer models, because in general for Ava, the cost and inference speed is very key. So it's important for us to have something like Inferentia in our model deployment pipeline.
It's tremendous to be able to experiment as well. There are lots of So some of the models that we look at are things like ones to help us determine what kind of a query something is, so that if it's not going to go down a chat route, how do we send it to the right agent afterwards? And specifically, we're also interested in identifying, I think I mentioned before, educational related queries, because the way we support educational customers, they go through a different path. So those things are important to us to be able to do on a broad basis, and being able to launch all those different models helps us. And I think in future, we're hoping to do even more exciting things with transformers.
That's great. One reminder to our viewers, we have Alex and Bing here answering your questions. So please keep the questions coming in on the chat. And Bing, you mentioned that you plan to continue using Inferentia for any future model deployment. I'm wondering what were you deploying your system on? What system were you using before to deploy your models before Inferentia?
Yeah. So I mentioned this a little bit in the presentation as well. We just use SageMaker endpoint for general inference. The important thing is that we need to usually test the inference time and kind of consider the inference process before we deploy the model, because the time and cost would be a concern for the inference of AVA transformers models. And there is a need to consider approaches to limit the inference cost and time, like, for instance, distillation or quantization. But I think when we have Inferentia in future, the process will be simpler for us, and there's definitely less need to do the analysis, and the process will be more scalable and easier for us.
So the big factors of that prompted you to try out Inferentia for Ava was because of the time and the cost and low throughputs.
Otherwise, productionizing these types of models previously was quite difficult because you had to do quite a lot. There was quite a lot of code to write and quite a lot of retraining and configuring to do between the two steps. Or you were using standard GPU instances, which don't scale very well. That can be expensive,
Well, kind of tagging along that point. So if there's someone in our audience who is on a team that's interested in setting this up for their own company, do you guys have suggestions of how they can set this up? And then also just an unrelated question, like, where did the name AVA come from? Is it an acronym for something?
Yeah, AVA is AutoDesk Virtual Agent.
Assistant. Okay.
Yes. Right. Going back to the question, so I think in general the process to start testing or proof of concept of Inferentia on top of any model, or not any model, but a model, would be very easy for now. I see a lot of improvements on the documentation and tutorial already, actually after I started the work. So the process would be easy, but maybe I think there's a need to actually understand if there's if there's a need to use Inferentia in the inference process before getting started, because for some of the applications, the cost or the hard problem would not be on the inference part, and it's probably not the same as AVA, because we need almost an answer at the same time when the customer comes to us asking questions. So yeah, I think that's the understanding. I think the testing and the analysis on the problem itself would be important.
Any words of wisdom? Oh, I was gonna ask, any words of wisdom, like that you've tried something and you would look back and say, oh, we should have done it. We should have just done it this way.
Yeah.
I think there are a lot of experiences like that. I think the key one is, I think, the one we mentioned, which is being very rigorous in making sure that the things you choose to support fit, I think, in the chatbot fit 3 criteria. One is they should have volume for demand, right? You should be very certain that the thing you're going to allow people to do with the chatbot is going to be wanted by many people, because it doesn't have to be the highest, necessarily be the highest volume question you get overall, but it should be one that you can answer as well. So the second thing is that, right? It has to be one that you can answer. There's a long history of people building chatbots that all they do is point people. They're just like an awkward way to show the fact from the website, and generally that's like not the optimal customer experience. So, you know, ideally there should be some reason to have a conversation with the chatbot in a way that helps you. And so that's the second thing that I think is important. So, you know, make sure it's high volume, but also an answer that you can solve, and then try and collect a representative variety of samples of data of how customers express this requirement, because they will surprise you. It's very, you know, it's quite surprising. Users come in with different viewpoints on what they're getting out of this interface, and they've been trained by search engines to put 2 to 3. Some people put 2 to 3 query keywords in and kind of treat it like a search box. Some people will write an essay that involves, you know, a very long and discursive kind of thing, and you need to be aware that both kinds of queries are going to come in, and that you need to train your model to be able to handle those variances in input very effectively.
Mm-hmm.
I think that's a big one for that, you know, you need to be able to clearly accept. And then I think my biggest takeaway always is to instrument, right? To have measurement points everywhere, so that you know, did we pick the right answer? When we brought the user to the solution that we thought they needed, was it the right one? Did they go away satisfied, or did they go away annoyed and come back a different day and use a different channel? Because that's essential in automating these values.
Yeah, that's very true. It's so frustrating when you're typing to the bot and it's just giving you like what's exactly on the website.
Absolutely.
Sorry.
Yeah.
Sorry, I think I interrupted Suraj with another question.
Oh no, that's perfect, because I think, Alex, your answer is very relevant to Froilan's second question, where he's wondering, how are you measuring feedback from the user? Is it actions that the user takes by either closing the chat box, or if continued engagement is actually a good signal to the model?
Yeah, there are a couple of things we monitor. The most straightforward way is we have a feedback system or surveys from the customers to give us a score. And we also monitor definitely the click-through rate and click-through rate. And actually, for a lot of our Ava intents, they are self-serviceable workflows where customers can go through the whole process by themselves. So the monitoring of the completion of the workflow is another thing we monitor. And for some of the questions where it's not a workflow process, we suggest some articles for the customers to read. And so the click rate on those is also a thing that we can monitor.
More engagement is definitely not better necessarily, right? Because sometimes you see customers who are not getting what they want, and they're just typing some variation of the same query over and over again and not getting the answer. So, you know, from a product management perspective, just kind of counting customer inbound, you know, chats as a metric won't align to necessarily the output that you want.
That's true. I guess the key takeaway over here is to really very strictly ring fence the intention of your model, and double down on exactly what are the metrics or behaviors that actually show that the model is doing what its intended objective was.
Exactly right. Absolutely. Yeah. And to remember that, like, your model is only one part of an overall embodied user interface. So, you know, you can have the most accurate model in the world, but if you don't have it exposed in a way that helps the user or communicates to the user, it probably won't help you as much as you hoped.
Yeah, exactly.
I'd like to switch gears a bit over here. I'm curious to know, what are you most excited about in PyTorch?
That's a great question.
Yeah, it's one of the things that I think the reason that we like PyTorch so much. The most exciting thing to me about PyTorch is the size of the community, especially in research around PyTorch, is very exciting. And you see some extraordinary stuff done. From a platform perspective, I'm really like the profiling work. I think the new stuff around profiling is really very exciting. We have a lot of intention to bring that to bear on our models because there's a lot to learn about where the expensive part of models is, what we can improve the iteration of, where we should spend our engineering resources to improve the quality of, and what we can do around, things, all sorts of other tricks that exist to kind of accelerate or improve the explainability of models, of transformer type models. And I think in the medium term, that's where we're going to be spending a lot of time, is being able to break open that black box is very much mediated by the ability of PyTorch to be that layer.
Yeah, for me, it's really exciting to see a variety of different projects in the ecosystem. There are just a lot of new ideas that I haven't heard before. So yeah, I think it's very exciting.
Yeah, to your point, Alex, I really like that the profiler allows you to dig into the stack trace and find out exactly what the cost is for each call that your model makes. And I think that's
Absolutely.
very informative when you try to optimize the flow of data through your model and through the decisioning process.
Yes, absolutely. And as you get to sort of we're as you move from the kind of scale of hundreds of thousands of queries to billions, if you're in a kind of a truly large consumer product, then it becomes even more important to be able to do that very refined kind of understanding of traffic.
Well, can I just take it one step further and ask, are there other interests? Is there anything in the ML world in general that's interesting to you? Any upcoming research that you're excited about? Not just in the NLP space, perhaps.
Sure. I can answer this in a very general sense. Maybe like a specific example of a thing that I'm interested in right now is, like I mentioned, going beyond intents, because I've been working on the intent model mostly for Ava, but I think there's a chance to actually explore more, and there's always a chance to explore more as there are new models coming every year, new ideas coming in, and there's always a lot of learning going on. And besides the actual models, it's also exciting to see new use cases. I think working in an enterprise, machine learning is also helping with a lot of answering a lot of business questions and help with decision making. So yeah, it's great to be in the machine learning world.
I think I would be remiss not to mention the work that our sister teams across Autodesk do, especially in the area of generative design. So we've had a tremendous amount of excitement with this idea of how you move from how you create a machine learning enhanced workflow for professional designers. So the sort of things that you see is some of the work. There was a recent paper called HouseGAN where the idea was that you draw a very schematic kind of picture where you say, these are the rooms that I want, these are their function, and these are how they should be connected. And the model will lay the optimal route out or lay the optimal building out. So you get the ability to then vary that and get 10,000 different examples of it. And there are other tools like that that allow structural optimization where you see the members or the struts or metal, and it almost looks like it's been grown, because it's what's happened is that they use a reinforcement learning technology to essentially, if you like, cut away all the unnecessary parts of the metal that aren't used, and so you get these kind of hollow looking, almost like bone-like structures that materials are used for. So I think our colleagues in the generative design workflow have done some astonishingly cool stuff, and I suppose if anyone is interested in that, certainly the Autodesk website has a lot of work on some recent projects there that I think are well worth engaging in. And definitely it's not the text stuff.
Nice. Yeah, it's always cool when ML kind of blends over into the 3D world and then it's able to kind of be creative in its own way. Yeah.
And this is the physical world. I mean, the really exciting thing about this is it controls robots. They kind of print this or weld it or form it in some fashion. And so you have a physical artifact that can be as big as a bridge coming from a machine learning model. And I think that's extraordinarily exciting and like feels very futuristic and science fiction-y to me. I think that's very much in that, feels like you're coming from the future kind of aspect,
It does. We have time for one last question. I think Bing alluded to this in her answer, but Anfidio is wondering if you plan to use AVA for more than just intent classification. Thank you, Anfidio, for your question.
Yes. So intent classification is just one example of model behind AVA. We have a lot of we have a couple other NLP models behind it. An example of it would be a case routing model. So when a customer creates a case within AVA, we have an NLP model behind it to try to classify out where the case, like which team the case should go to. And that would save a lot of time for a case resolution. It's also helpful for increasing customer satisfaction. So absolutely, we have a couple models behind AVA besides intent classification, and we're thinking about adding more. So.
Yeah, and slot filling in particular is a very good suggestion there. Looking at the different mentions that users make is something that we are looking to further integrate with the kind of task widgets that we do. It's a great question.
All right. We are at the end of our stream. I want to thank Bing and Alex for taking out the time today and talking to us about AVA and your entire experience of deploying a massive system with high throughput, low latency, and clearly at a low cost and high benefits to the company. I also want to thank all of our viewers on Facebook, YouTube, and Twitch for all of your questions and just joining us here today. This was episode 3 of PyTorch Community Voices. We will be meeting again next week at the same time on Wednesday. Be sure to join us again, and I look forward to seeing all of you again.
Yeah, thank you
Thank
all
you.
again.
Thank you.
Bye.
We will post the link to their blog post. So it's a write-up of summarizing what they've talked about. So look out for that in the descriptions.
Yeah, I think I saw a question suggesting that the link wasn't put up long enough. So maybe we can have the link on the screen for some time and let people just go through and read more in detail of how you built AVA.
Great.
Thank you.
Thank you. We enjoyed this very much.
Thank you.
Thank you.